Good morning students. Today we are going to start our new chapter, that is rational and irrational number. So let us start with the rational numbers. What are rational number? A rational number is any number which can be written in the form of a upon b, where a and b both are integers and b is never equal to 0. It means rational number includes all the positive integers, all the positive fractions, zero as well as negative integers and negative fraction. Right? Over here I said negative integers and the positive integers. Positive integers will be what? 1, 2, 3 and so on. So these can be written in the form of a upon b, like 1 upon 1, 2 upon 1, 3 upon 1. Positive fractions like 2 upon 3, 1 upon 3 or 1 upon 5 and so on. These are the positive fractions. 0, that is also a rational number. Negative integers like -1, -2, -3 and so on. And last I said negative fraction. So for example, -1/2, -1 upon 3, -2 upon 3, all these are rational number, right? So it is clear what are the rational numbers. So next is, what are the properties of our rational number? We have learned about that what are rational number, then what are the properties. So first property of the rational number is that whenever we are going to add, subtract, multiply or divide the rational number, the answer will always be a rational number. What I am saying? I am saying additional of a rational number is always a rational number. For example, if I am taking 3 upon 4 plus 5 upon 7, what the answer will come? It will be 41 upon 28, right? So either it is a rational number or not. Yes, because it can be written in the form of a upon b, and 41, 28 both are integers and 28 is not equal to 0. So this is what? It is a rational number, right? So what we can say, whenever we are going to add two rational number, the answer will always be a rational number. Now I said for the subtraction, if I say 3 upon 4 minus 5 upon 7, what will be the answer? Answer will be 1 upon 28. What is this? 1 upon 28. Again, it is what? A rational number, right? That means whenever we are going to subtract two rational number, the answer will always be a rational number. Third, if you multiply two rational numbers, what will be the answer? It will be 15 upon 28. It is again a rational number. Fourth, whenever we divide two rational number, what will be the answer come? So 21 upon 20. So is it a rational number or not? Yes, it is also a rational number, right? So whenever we are going to add, subtract, multiply or divide two rational numbers, the answer will always be a rational number. This is a first property of rational number. So our second properties of the rational number is what? The set of rational number is commutative for the operation of addition and multiplication. What I am saying, it is commutative for addition and multiplication, right? What I am saying, that means if we are going to replace the position of the number, the answer will be same. For example, if I say 1 upon 5 plus 3 upon 7, it will be equal to 3 upon 7 plus 1 upon 5. This is the commutative property, right? You can check the answer. What will be there? 7 plus 15 upon 35, and over here same 35, 15 plus 7. How much? 22 upon 35 and 22 upon 35, right? So in case of addition, the rational number are always commutative. Same, I have said they are commutative for the multiplication, right? So 1 upon 5 into 3 upon 7 will be equal to 3 upon 7 into 1 upon 5. We can check it. So for this, answer will be what? 3 into 1, 3, 5 into 7, 35. 3 into 1, it is 3, 7 into 5 is how much? 35, right? At both the side, we are getting the same answer, right? So we can say that a set of rational number is always commutative for the operation of addition and multiplication. Third property of the rational number is what? The set of rational number is associative. What I am saying, it is associative for addition and for multiplication, right? What does it means? If I am having a number like 1 upon 2 plus 1 upon 3 and then plus 1 upon 4, it will be same as that 1 upon 2 plus 1 upon 3 plus 1 upon 4, right? So if you calculate this one and if you calculate this one, you will get the same answer, right? That means the rational number is associative in addition. Same in case of multiplication, if I am writing 1 upon 2 into 1 upon 3 and then into 1 upon 4, it will be equal to 1 upon 2 into 1 upon 3 into 1 upon 4, right? So if all the terms are of addition, right, then the rational numbers having the properties of as being associative in form of addition as well as in the multiplication. Our next property is what? For every rational number, there exists a rational number which is having its additive inverse. So I am saying next property is what? Having additive inverse. That means if a number is there, A, then it is always having an additive inverse, that is minus A, such that when we add both the numbers, you will always get 0, right? So if I say that 5 upon 8, what is the additive inverse of that? That means what should be added to 5 upon 8 to get 0? So it will be what? Minus 5 upon 8. So answer will be 0. That means if a positive number is there, its additive inverse will be negative. If a negative number is there, its additive inverse will be positive. For example, if I say minus 2 upon 3, what is the additive inverse? So additive inverse means to say what should be added over here to get 0. So minus 2 by 3, its additive inverse will be plus 2 upon 3. So when you are adding, you will get 0. This is what? Additive inverse. That means for every rational number, there exists a rational number such that number plus its additive number is always 0. Next property is what? Multiplicative inverse. Just like additive inverse, we are having the multiplicative inverse. So what is that? For every rational number A, there exists a rational number 1 upon A such that when we multiply number and its multiplicative inverse, the answer will be 1, right? For example, if I said I am having 8 by 3, what is its multiplicative inverse? Its multiplicative inverse will be 3 upon 8. Why? Because if I multiply 8 by 3 into 3 by 8, what will be the answer come? 1. That means multiplicative inverse is that number which when is multiplied to the number itself, it gives the answer 1. If I take another example, for example, I am taking 1 upon 2. What is the multiplicative inverse of this? So multiplicative inverse of this will be 2 upon 1. Why? Because when 1 by 2 and 2 by 1 are being multiplied, so answer will be 1. This is what? Multiplicative inverse. Our next property of the rational number is what? Distributivity. The property of distributivity holds in the set of rational number. What I am saying, for example, with the example I am showing you, if the example is 2 by 7 multiplied by 1 upon 6 plus 1 upon 9, right? So it will be equal to 2 upon 7 into 1 upon 6 plus 2 upon 7 into 1 upon 9, right? This property is called distributive, right? Either you calculate this one or either you calculate this one. You will get the same answer because over here the bracket is there, right? That means 2 by 7 is to be multiplied to the 1 upon 6. Then addition sign is there. Then 2 upon 7 is to be multiplied with the 1 upon 9. This is our distributivity property. So till now we get all the properties of the rational number. So let us remind. So first property was that when we are going to add, subtract, multiply or divide the rational number, we will always get a rational number as the answer. Second property was that the set of rational number is always commutative for the operation of addition and multiplication. Third is what? The set of rational number is always associative. Fourth, the number is always having a additive inverse. And what is the additive inverse? When the number is being added with the additive inverse, the answer becomes 0. Next is multiplicative inverse. For every rational number, there exists a multiplicative inverse, and when a number is being multiplied by with the multiplicative inverse, answer is always 1. And last, it is the distributivity property, right? And all the rational number holds this distributive property. So a very important property of rational number is what? The denseness property of the rational number. Now this property is different from the integers. Now if I said two integers like 3 and 5 and I said that calculate or write the integers in between 3 and 5, it will be 4 only, right? If I am saying write the integers in between 1 and 7, so it will be 2, 3, 4, 5 and 6, right? That means they are having a finite numbers in between. But when we come to the rational number, right? So whenever I am having a rational number, for example, if I write the numbers in between 1 upon 2 and 1 upon 3, so we are having infinite number of rational numbers in between two rational property, and this property is called denseness property. So what it says, that between any two different rational numbers there are infinite number of rational numbers, right? So further we are going to show how to calculate the numbers in between two rational numbers. As I said, we can calculate infinite numbers, right? So further we will discuss about that. So this is our example. Calculate the rational number between 1 upon 2 and 1 upon 3. As we have learned in the earlier class, that method I am going to explain over here. What you do, 1 upon 2 multiplied by 30 multiplied by 30. What you will get? 30 upon 60, right? 1 upon 3 multiplied by 20 multiplied by 20. You will get 20 upon 60, right? So in between 30 upon 60 and in between 20 upon 60, many numbers you can calculate. 20 upon 60 and 30 upon 60. The numbers will be 21 upon 60, 22 upon 60, 23 upon 60 and so on. This is the method that you have learned in the earlier class, how to calculate numbers in between the two rational numbers. But in our next example or in the same example, I am showing you the another method with which you can calculate infinite numbers of in between. Over here, when we are multiplying with this one, you are getting a finite numbers in between. Or either if you want to calculate more numbers in between, you need to change the digits over here. But in next, I am going to tell with the same method how can you calculate infinite numbers in between two rational numbers. So what I said, how to find many rational numbers in between two given distinct rational number. So I am going to explain you the method how to calculate that, right? Let us given we are having two rational numbers a and b. Over here I am saying a and b are not the integers, these are the rational number. Then your first rational number in between a and b will be half of a plus b. This is the first rational number in between this. For example, if I am taking 1 upon 2 and 1 upon 3. right? What will be the first rational number in between this? It will be Q1 is equal to half of 1 upon 2 plus 1 upon 3. How much it will be there? LCM will be 6. So 3 plus 2. So it will become 1 upon 2, 5 upon 6, and hence answer will be 5 upon 12. So 5 upon 12 is the first rational number in between 1 upon 2 and 1 upon 3. Now, this is the first rational number. If I need to calculate another rational number, what it will be? Over here, I have calculated Q1. So, next rational number will be what? Half of Q1 plus B. Right? Now, over here, I am saying half of Q1. Q1 what I have calculated? 5 upon 12 plus. B was what? I said this is A and this is B. B is 1 upon 3. Right? So, half of, what will be the LCM? Right? 15 plus how much? 12. So, answer will be 1 upon 2 into 27, 36. So, it will be 27 upon 72. Hence, the sequence now has become, it is 1 upon 2. Then, it is, what was the next number? 5 upon 12. Then, what was the next number? 27 upon 72 and 1 upon 3. So, in this manner, we can calculate numbers in between this, the numbers in between this, and the numbers in between this. Right? So, this is the method how to calculate many rational numbers in between two given distinct rational number. Right? If two numbers are there, just add both the numbers and divide it by 2. Once you get one number, then make a sequence and then add both of the number and then divide it by 2. You will get numbers in between. If you add this one and divide it by 2, you will get the number in between. If you add this one and divide it by 2, you will get this number. So, our formula is what? To calculate the number, it is half of A plus B. Right? So, with that, the sequence will go on. If I said calculate the 7 numbers. So, first calculate in between this. One number is you will get calculate, then in between, and so on. You will get to know how to calculate the many numbers in between two rational numbers. So here I am going to solve a complete example about how to calculate the rational number. Over here I am going to calculate 4 rational numbers in between 1 upon 4 and 1 upon 3. So over here my A is 1 upon 4 and B is what? It's 1 upon 3. Now, as I tell you, what is the formula? Q1 is equal to what? Half of A plus B. So, it will be what? Half of 1 upon 4 plus 1 upon 3, right? And when you add this one, you will get 1 upon 2, 3 plus 4 upon 12, and hence answer will be 7 upon 24. So, 7 upon 24 is the number in between 1 upon 4 and 1 upon 3. So, the sequence will become 1 upon 4, 7 upon 24, right? I have calculated Q1. Now, Q2. Q2 I can calculate in between this or either in between this. I am taking this one. Now, if I am taking these two pair, so A will be this and B will be this. Now, this is A and this has become B. Again, half of A plus B. What it will be? Half into 1 upon 4 plus 7 upon 24. What will be the solution for this? It will become 1 upon 2, 6 plus 7 upon 24. So, here the answer will become 13 upon 48, right? So, this 13 upon 48 is what? It is the number in between 1 upon 4 and 7 upon 24. So, the sequence has become 1 upon 4, then 13 upon 48, then 7 upon 24, and then 1 upon 3. So, I have calculated two numbers over here. Now, I can take this pair also, right? So, now if I am taking this pair, this has become A and this will be B. So, what will be the Q3? Q3 will become 1 upon 2, 7 upon 24 plus 1 upon 3. So what will be the solution? It will be 1 upon 2 plus it will become 7 plus 8 upon 3, and here it will become 7 plus 8. It will be 15 upon, sorry, it will be 24, right? So it will become 15 upon 48. So Q3 is what? It is the number in between 7 upon 24 and 1 upon 3 over here, right? So the sequence has become 1 upon 4, 13 upon 48, 7 upon 24, and then 15 upon 48, and then 1 upon 3, right? So how much numbers we have calculated? Q1, Q2 and Q3. Now I want to calculate the fourth one. I can take either this pair, either this pair, either this or either this. I can take any one of the pair. So Q4 I am taking this. So half of 15 upon 48 plus 1 upon 3. When you solve this one, you will get the answer 31 upon 96. So here is our answer becomes 1 upon 4, then 13 upon 48, then we have calculated 7 upon 24, then we have calculated 15 upon 48, and last 31 upon 96, and what was our number? 1 by 3. So these are 1, 2, 3 and 4. These are the 4 rational numbers in between 1 upon 4 and 1 upon 3.